In this episode, we shall discuss about the supercomputer, especially the definition, characteristics, common components, examples, and applications of supercomputer will be discussed here. The definition of supercomputer. A supercomputer is a high-performance computing system designed to perform complex and large-scale calculations at speeds significantly faster than conventional computers. These machines are used for scientific research, engineering simulations, climate modeling, and other computationally intensive tasks. Characteristics of supercomputer: high processing speed, measured in flops, floating point operations per second. Supercomputers execute trillions to quadrillions of calculations per second. Parallel processing, they use multiple processors working simultaneously to perform complex computations. Massive storage capacity, supercomputers require large amounts of storage to handle vast datasets. High memory capacity, random access memory in supercomputers is much larger than in traditional computers, enabling faster data access. Advanced cooling systems, due to high energy consumption, they use liquid cooling and other advanced cooling technologies. Custom-built hardware, unlike regular PCs, supercomputers use specialized processors, interconnects, and optimized architectures. Scalability, designed to expand computational power by adding more processing units or nodes. Now the types of supercomputers. Vector processing supercomputers use vector processors that handle multiple data elements simultaneously. Then tightly coupled cluster supercomputers consist of interconnected nodes working as a single system. Then loosely coupled cluster supercomputers, multiple computers connected via a network, each working on separate tasks. GPU-based supercomputers use graphics processing unit (GPUs) for parallel computations. Quantum supercomputers based on quantum mechanics principles, offering exponentially faster computations for specific tasks. And then the components of supercomputers: processors, CPU and GPUs. High-speed processors designed for massive computations. Memory, RAM and cache, large and fast memory for quick data access. Storage system, high capacity SSDs, HDDs or tape storage for handling vast datasets. Interconnects, high speed networking components like InfiniBand for rapid data transfer between nodes. Operating system, usually Linux based due to its flexibility and efficiency in handling parallel processing. Cooling systems, liquid cooling or immersion cooling to manage heat generation. Software and applications, custom-built software for simulations, AI data analysis, and scientific research. Now the examples of supercomputers. Fugaku, Japan, developed by Riken and Fujitsu, currently one of the fastest supercomputers. Summit, USA, built by IBM for Oak Ridge National Laboratory. Sierra, USA, used for nuclear weapon simulations and scientific research. TIA-2, China, previously the world's fastest supercomputer. Lumi, Europe, a leading supercomputer in Europe designed for AI and research applications. Now the applications of supercomputers. In weather forecasting, predicting hurricanes, climate changes, and extreme weather conditions. Medical research, drug discovery, genomics, and personalized medicine. In aerospace and engineering, it is simulating aircraft, rocket designs, and fluid dynamics. Artificial intelligence and machine learning sector, training complex deep learning models. Then nuclear research sector, simulating nuclear reactions and weapon testing. Oil and gas exploration, analyzing seismic data for resource discovery. Cryptanalysis and cybersecurity, cracking encryption and securing communications. in financial modeling, high frequency trading, risk assessment, and economic simulations. Now we shall test our learning outcomes. Number 1. What is a supercomputer? A high-performance computing system designed for complex calculations, or a gaming computer with high-end graphics. Which one is the definition of supercomputer? Option A is the correct answer. A high-performance computing system designed for complex calculations is a supercomputer. Next test. Which of the following is a key characteristic of a supercomputer? Option A, high parallel processing capability. Option B, uses a single processor. Which one is the correct answer? Option A is the correct answer. High parallel processing capability is a key characteristic of a supercomputer. Next test. Supercomputers require which of the following for efficient operation? Option A, no cooling system. Option B, advanced cooling systems like liquid cooling. Which one is the correct answer? Correct answer is B. Advanced cooling systems like liquid cooling is required by supercomputers for efficient operations. Next test. Supercomputers execute calculations at speeds measured in option A, flops, floating point operations per second, or GHz, gigahertz. Which one is correct answer? Supercomputers execute calculations at speeds measured in flops or GHz, gigahertz. The correct option is A. Flops, floating point operations per second, is the correct answer. Supercomputers execute calculations at speeds measured in flops. Next question. Which type of supercomputer is based on quantum mechanics principles? Option A, quantum supercomputers. Option B, vector processing supercomputer. Which one is the correct answer? Which type of supercomputer is based on quantum mechanics principles? Option A, quantum supercomputer is a type of supercomputer which is based on quantum mechanics principles. So the correct answer is option A. That's the end of this episode. Thank you very much.